welcome to the next video in the Rasters series of the Victory Registers series, sub series. Okay, right. We talked in the last video about the two raster registers, 36868 and 36867. Right, 36868 being the top 8 bits of a 9-bit number, which represents where on the screen the rasters are at the current time. Okay, so what does this number actually mean? Well, I've done a little program here, and basically what it does is it works out the highest value of the 36868 register, which is the top 8 bits of the raster number, and it basically it peaks it and compares it whether it's bigger than the last peak, and if it is, it prints it out. And it does it all again. It sets the biggest peak to the current peak and goes through it again, and eventually it'll come up with the highest possible value you can get out of that register. So I'll just run it. There we go. Will you run? It's paused. There we go. There we go. So it started off at 64, obviously 127 bigger than that, 155. And what it is the highest number. I've never run it before, so I know. Is 155. So what does that actually mean? Well, it means that the top 8 bits of that 9-bit number is 155, which if you look, let's have a look. Calculator, there we go, programmer, 155, binary. Right, is this number. Right, if you shift it one to left by multiplying it by 2, it's going to let me do it. It's going to let me. Bit shift. Here we go. Bit shift. Logical shift. Rotate. It's not saying whether it's a left or a right shift, is it? Okay. I'm not terribly sure what this is. Tell you what, I'll just go into decimal and multiply it by 2. That's easier. Decimal. Is it going to let me do it? Multiply by 2 equals, there we go, 310. So there you go. That's that shifted one to the left, and you get a value of 310. So that means the maximum value of that register is going to be 300. The line number is going to be 310. So if you add the bit in the 36867 register, just assume that it goes to 1, then because it's going to be alternative 0 and 1. That will be 311. So the values you can have for where the line is 0 to 311. Now you'd have thought it'd have been, this is the English version, PAL version, so you'd have thought it'd been 625, but it's not. What it does is 0 to 311 for one field, then it goes, say the odd field, and it goes back and does it 0 to 311 for the even field. So basically it only ever goes up to 0 to 311. Now you'd have thought that you'd have had 0 to 311, which is 312 values, and then maybe 0 to 312, which is 313 values to add up to 625, but it doesn't do that. So I'm assuming it's taking the two half lines at the beginning and end of the odd fields as to be one line. So 0 to 311, so it's 312 lines each field. So basically that's what those numbers represent. Right, okay, so a little bit of fun. What shall we do? I'll show you. You can't really use it in BASIC because it worked. They changed too quickly. But I've written a couple of which one? Right. I'm not really sure. Yeah, this is probably it. Yeah, this is it. Right, okay, basically I'm using the raster register, the 368 register, uh, to change the border colour when it hits a certain line. In this case, it's 111, which is the bottom of the screen, bottom of the window, should I say? And then it changes it from cyan to red, and then when it gets to 155, it changes it back to cyan. So when it comes back at 0, it comes back down, and until it's 111 again. And I can do that for any two positions, to be honest. Let's call it, oh, I don't know. Let's call it 60, I don't know, 70, 76, 70, 74, and 64. There we go. So, there we go. There you go. So it's in 64, changing to red. Then when sorry, yeah, that's basically it. Well, first of all, it comes down. It says, is it 74? And if it is, it changes it to cyan. And then it comes back and it says, is it 64? If it's 64, it changes it to red. And then it waits. Then it just keeps looping, and then it gets to 74, changes to cyan. So basically, you just get like a stripe. You can change the size of the stripe by altering the raster line numbers where it changes. So that's just a little fun program just to show you how you can use the rasters to do timing for certain events, what have you. Right, okay. I did have another one, another little fun program that I'd like to show you. It's one using the 36867 registers, and I'm not sure where it is. Maybe that's it. Yeah, this might be it. Yeah, basically, the 667 register is the lowest bit, obviously. So that's every other line. It's going to it changes from red to red to cyan, and then cyan to red to cyan. So basically, so each one of these lines is not actually a single raster line, because like I said, there's two fields. It does it for both fields. So each one of these lines is two raster lines. I'm working on one to get it to a single raster line, but it's a little bit more complicated than I thought it would be, and I'm working on that at the moment. But to be honest, the results that I've got so far is it just looks pretty poor. It's like flashing. It just flashes so fast. It's hard. Probably give people with epilepsy a bad time. But yeah, these are two raster lines each. Changes every time the bit in the 36867 register changes. It changes from either a red to a cyan or a cyan to a red. This little, see this little tiny little stripe of blue here. This is the time where it's comparing what it, where it's trying to make its mind up whether it's with the 6/7's a 0 or a 1. So there's a slight delay before it actually changes. And I've actually looked this up, and it takes about 50 microseconds to complete one complete raster line, and then it takes 10 microseconds for the retrace. So that's 60 microseconds. So if you can imagine, this must be like well below a 20th of that, isn't it? I'd say maybe 30th or 40th, 30th. 30th of 60 microseconds is 2 microseconds. No, that can't be right. Oh, God. It's not a lot of microseconds. This little gap here. So I would say at the most, I would say